Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of tangent graph. As per the problem, graph the trigonometric function and we are given this transformed tangent function. The first step is to write the general equation of a transformed tangent function. Different teachers use different letters for A, B, H and K, but that doesn't change the resulting transformation. If we compare the given equation with this general equation, we can see that the value of A is equal to negative 1 over 2, B is equal to 1 because there is this invisible 1 here in front of the parentheses inside the tangent function. H is equal to 3 pi over 4. There is a negative sign in the given equation and the general equation, so that's why h is equal to positive 3 pi over 4 and k is equal to 0 because there is no number term being added or subtracted. Next, we can find the period of this transformed tangent function. We'll use the period formula. Pi is the period of the tangent base function or parent function. The value of b is equal to 1. So the period of this transformed tangent function is pi. We can use mapping rule to find the points that lie on this transformed tangent function. The mapping rule is x comma y is a point that lies on the base function or the parent function, and those points get transformed due to the a, b, h and k values. Now we can sub in the a, b, h and k values. X over 1 will just be x. K value is equal to 0, so we can ignore it. So this is the mapping rule for this given transformed tangent function. Now we can prepare a table of values for the parent function. The parent function is y equals tan x. We should use x values for one full cycle. As we know, tangent function graph has vertical asymptotes. So the first cycle about the origin has the vertical asymptote at negative pi over 2. So we can cover x values for the full cycle starting from negative pi over 2 to positive pi over 2. And the values in between can be at negative pi over 2 there is a vertical asymptote, so the y value is undefined. At negative pi over 4 the y value is negative 1. At 0 it is 0. At pi over 4 it is equal to 1. And at pi over 2 it's undefined. Now we can use these values to prepare the table of values for the given transformed function. So in the x column, we'll use the x coordinate from the mapping rule. And in the y column, we'll use the y coordinate from the mapping rule. Let's start with the first point. The first x value is negative pi over 2. So for the first point for the transform function, we do negative pi over 2 plus 3 pi over 4. So we use the x and y values from the table of values of the parent function or the base function. The negative pi over 2 plus 3 pi over 4 is equal to pi over 4. We get pi over 4 by finding a common denominator and then combining the fractions. For the y coordinate, we have to do negative 1 over 2 times undefined, which will also be equal to undefined. So the vertical asymptote at negative pi over 2 in the parent function has been translated to pi over 4. There is a horizontal translation, 3 pi over 4 units to the right. Now we can use the second point from the parent function table of values, negative pi over 4 . This is equal to 2 pi over 4, which can be reduced to pi over 2. For the y value, we have to do negative half times negative 1, which will be equal to positive half. Now we can use the third point. 0 plus 3 pi over 4 will be equal to just 3 pi over 4. And then negative half times 0 will be equal to 0. For the fourth point, we should do pi over 4 plus 3 pi over 4, which is equal to just pi. And for the y coordinate, we should do negative half times 1, which is equal to negative half. For the fifth point, pi over 2 plus 3 pi over 4 will be equal to 5 pi over 4. We get this answer by finding a common denominator. And then for the y coordinate, we do negative half times undefined, which is equal to undefined. So the vertical asymptotes for one cycle are at pi over 4 and 5 pi over 4. Now we can plot these points to graph the given transform tangent function. So the first vertical asymptote is at pi over 4. The next vertical asymptote is at 5 pi over 4. The middle point of these two vertical asymptotes will be 3 pi over 4. We can find the middle point by finding the average of the x values for the vertical asymptotes. That can be done like this. We can add the fractions in the numerator. Pi over 4 plus 5 pi over 4 is equal to 6 pi over 4, which can be reduced to 3 pi over 2. And 3 pi over 2 divided by 2 can be simplified to 3 pi over 4. So that's how we get the middle point. The quarter point between the first asymptote and the middle point will be pi over 2. So we can find it the same way that we found the middle point 3 pi over 4, and the third quarter point between 3 pi over 4 and 5 pi over 4 will be pi. Now we can plot the points. At pi over 4, the y value is undefined. That's where we have the first vertical asymptote. At pi over 2, the y value is half, so it'll be somewhere here. At 3 pi over 4, the y value is 0, so that's the point on the x-axis. And at pi, the y value is negative half, so it's below the x-axis, so somewhere here. At 5 pi over 4, the y value is undefined. That's the second vertical asymptote. Now we can join these points in the form of a curve. So this is the graph of the given transform tangent function. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.